Hello. Today I want to talk a little bit about relays. At my one of my last projects, I used a relay to power on and off my power supply from my WLED project, and just out of curiosity I searched a little bit online to see what videos are uploaded about relays. And well, there are some good videos out there, but I think most of them are missing the point of a relay and when to use it, why to use it, and why it is used almost everywhere where there is an automation, in cars, in industrial machines, and so on. So right before getting into it, I will be talking about this in general terms. So the following principles will apply to relays, but also to contactors, which are also relays but a little bit bigger, and they have another name probably for making an easy separation between two, because usually contactors are used in high voltages and relays are used in low voltages, but again the principle is the same. So first of all, why would we use a relay, and what it actually does? So as we can see here, this is the inside of a relay. They are in different shapes and sizes, voltages. I mean, if it's in automotive industry, there will be 12 and 24 volts relays mostly, but also there are on bigger voltages also. But for controlling, I think in the automotive there are 12 and 24 volts, and in residential or in other industries there are the ones that work with 220 AC for controlling them, or 24 volts controlling a higher voltage, and so on. So the basic build of the relay is, you can see we have a coil that has a metal core inside, and when this coil is energized, that means when we have voltage powering the coil, the electromagnet will attract this little piece, and with that we will make contact between this part and this part here. So in that case, the other circuit, which is on the other two contacts of the relay, will get activated. Also, unfortunately, I only have this kind of relays here today with 4 contacts. There is another one which has 5 contacts. There is another pin here in the middle. As you can see, there is a place here for it, but it's not active. Also here we have the place for the fifth contact, but it's not there because these are just simple on-off relays, or let's say normally open relays. Now what this means? Okay, so let's draw here the coil first. Okay, so let's say this is the coil. Sorry for my drawing skills. And here we have the contacts. Let's say this is one, and let's draw the 5 contact relay, because it will make more sense if you find one of those. And in most of the relays, one of the contacts is already closed before doing anything. So yeah, there are other variations where there are two open contacts and so on. So we will call this contact normally closed, and we will call this contact normally open. So what you need to know, these are the names in off position. So the relay is in off position, which means that the coil is not energized. So let's take for an example, we want to, I don't know, start a 12 volt DC motor here, which has a consumption of about let's say 30 amps. You will find it mostly car fans will have 30 amp rating fuses, and they are mostly controlled by a relay. Okay, on this side we have the battery. I hope that I'm not getting out of the picture. So we have the battery here, and we will supply the contact for the relay through a fuse, which should be a 30 amp fuse also, or if the nominal current of the motor is 30 amps, then you will need a bigger one, let's say 40, and so on. So this fuse from the battery, positive in this case, let's say that this will go to the plus of the motor. Okay, and we have the coil here, which should also be connected, let's say, to a switch. We have a switch here, and we will just represent it like this. Let's say this is a switch on the, I don't know, on the car's dash or something like that in this situation, and we have this connected to ground. Yes, something like this. And we also have the motor, the other side, connected to ground. Okay, so what will happen here when we switch on our little switch from the dashboard? Current will go through the coil. It will attract the contact from this position, from the normally open. It will close this contact, and then the fan will spin. Yes, and also when we take off the current from this coil, then the relay contact will go back to the open position, and yeah, the motor will not run. Why have 5 contacts? Well, I don't know, you can have a small feedback into the dashboard. Let's say we have a little light here. Oh, sorry, here we have a, let's say, a green light. And also from this point we can have, let's say, a red light. And of course these both are connected to ground. So what happens when the relay is not active and the fan is not switched on? We will have the green light showing up in the dashboard, and when we will switch the relay, we will energize the coil. When we move the contact to the other position, the fan will start, and also the green light will go out and the red light will come in. So we have some kind of feedback to what's happening with our relay. Okay, so this is one usage scenario. Okay, but why are we doing this? Why aren't we switching the motor directly? Now, this is the good part of the relay, and this is mostly why it is used. Let's say we have the battery here of the car, and we have the fan right here. Okay, yeah, and we can connect it here to ground and so on. So we have the relay here mounted, and we are controlling it. Let's say there are, I don't know, we have the dashboard here and the switch is here in the dashboard. Okay, so what's happening here? In order to start the motor with this switch, we would need all these very thick wires. Let's say, I don't know, this is 2.5 millimeters section wires to run from the motor into the dashboard, and also back to the motor again. So from the battery to the dash, from the dash to the motor. And here we can use a really small switch if we are using the relay, but if we want to control 30 amps, we will need a really large switch, so it will be very big in size in order so it can conduct the 30 amps from the motor. Now, this is not economic because you will have to run really thick wires, you will have to find a really big switch and so on, and this is just not economical. And another thing to consider, we can switch with a really small current the coil on, so here we will need very thin wires for us to control the relay, and we can have the thick wires only on this distance, and here we can have very small wires, maybe 0.5 millimeters, and these ones are 2.5 millimeters. This is just an example. Of course, you can scale it up to anything. And let's say you have 100 amps motor here, and then it's the same. We will need maybe for 100 amps, who knows, maybe 6 millimeter wires, maybe larger. I'm not sure now, but anyway, this will stay the same, 0.5. So for the coil, it's enough that we have this little switch in the dash, and we are not using for 100 amps you will need a really large switch in order to maintain the current. Okay, everything is clear. So if we are looking at cars, the biggest consumption comes from the starter. Yes, and everyone who has taken a look under the bonnet should know that the most thick wires in the car are going from the battery. Okay, let me just take another. So those are going from the battery directly to the starter motor. Let's say this is the starter. Okay, and here we have a solenoid in the starter which also engages the gear to the flywheel, but also inside there are two big contacts which act as a relay for conducting the current to the starter. So these are, I think, 35 square millimeter section wires, and you would imagine what would this mean to have these wires connected to the ignition key. So I hope you understand. So this is the first thing why using a relay, and you can imagine we can control the relay with a small wire like this instead of using a switch and wires like this or even bigger in diameter. Okay, the other reason why it's good to use relays, because let me just do this little drawing again. Okay, so in this case both power supplies are connected to the same battery. There is also a good idea to have a fuse on the coil of the relay, I don't know, maybe 1 amp or something like that, just to have this circuit also protected. We are here protected with this fuse, but also we should protect us with this one. So in this case the power supply is the same for the coil and also the rest. Now another thing to consider, and this is maybe mostly used in contactors, but also in my latest project I used a relay. Yeah, let's draw the coil again. So this is the coil of the relay, and here we have the contacts. I will just draw only one because you get the idea. Okay, so in this case I used 5 volts for the coil. Yes. Okay, this is ground. So I have only 5 volts DC here, and for separation I'm switching actually AC, and that's 220 volts AC. Okay, so I already wrote it. So AC 220. So like this we have a separation. Let's say that this is somewhere in I don't know, we have this in a box somewhere which is out of reach, and we have all high voltages here, and going to different consumers. So I don't know, a bulb, motor, an AC, whatever, we don't care. So this is high voltage. It's not really high voltage, but we will call it like this, high voltage. And the switch that we will use for the coil, it can work on 5 volts. So even if we open up the switch and touch these wires, we are protected from the 220. So here's another advantage: you can separate the dangerous voltages from the non-dangerous ones. And this is another thing to consider when where to use a relay. Okay, and now I think we have pretty much everything covered. If I forgot something, well, I hope not, because these are the usage scenarios for the relays. And I just want to show you something. Now we are testing this this controller, and this controller has outputs for about 7 different things, and all the equipment connected to this has much higher currents than these wires or this controller could ever handle. So we could not make the controller so small if this would to control everything directly and not through relays, because I will show you just in a minute how many relays we must fit inside the little controller in order not to use them. Of course we could use solid state relays, or transistors, but anyway, transistors need really large heat sinks and so on. So this is the simplest thing to do: use relays, and we can keep everything nice and small and put the relays outside or somewhere in a part that we are not bothered by them, and also it makes a real big sense economically. You know the prices of copper these days, so it only makes sense to use as less copper as we can. Okay, so I will show you guys what I'm talking about, and just compare and imagine what it would look like to have all these relays inside this, and how bulky would be a controller if everything was built into it. Okay, so we are out here with the controller, and actually this is an AC controller, and it's controlling. I will just take this bulb here because this means the compressor, the AC compressor, is active, and we have a fan connected to it, and we can change the speeds, yeah, and the temperature and so on. But the thing what I wanted to show you is, look at the size of the controller, and these are all the relays we need for driving everything that this controller does. So imagine fitting all of this inside. So it's not even technically feasible, and of course much less economically, and yeah, so this is why we use them. Okay guys, I think we are done for today. Let's try to switch this off. Yeah, now it's only on ventilation. Well, anyway, so that's it for today. I hope you learned something from this video, and well, don't forget to like and subscribe. I hope we will see you next time. Bye bye.